Okay, guys. So if we have like simple beam like this one, and this is the support. Sorry, my handwriting will be not very good because I'm using the mouse only. So if we have a simple beam, one support is roller and one support is hinge, and the span, this is the span L. I will assume this span is, let's say, 5 meters. Okay, and we have applied load, like uniform load. Okay, this uniform load we call it Q or W. W equal to, let's say, 2 kilonewton per meter. Okay, and the span is L equal to 5. Okay, and we have the supports A and B. From your memory, how many reactions we have for this one? 3. We have 3 reactions because A is hinge, so we have RA, or let's say YA, because we have 2 reactions at A, YA, and horizontal reaction at A, we call it XA. So we have XA and YA, and here because it is roller, so we only have YB. Okay, how can we find the reaction for this one? To find the 3 reactions, we have 3 equations. Measure the forces in X direction should be 0. This is the first one. Summation the forces in Y direction should be 0. This is the second one. Summation the forces, summation moment at any point should be equal to 0. So this 3 equation we have to get the reaction. The first thing to find the reaction, we need to know what is the load we have. The load we have is only the uniform load 2, and we cannot deal with the uniform load, so we need to concentrate the load. So we will concentrate the load at the middle because it is rectangular load or uniform load. So this will be the concentrated resultant. How can we find the resultant? The resultant will be the load Q multiplied by the length L. So this will be 10 kilonewton. Okay, so this is the only load we have. If we apply this equations to find the reaction, so for X direction, what is the forces we have in X direction? We have only one. Only one. XA, right?
XA, yeah.
So XA should be 0 because we only have XA. Okay. If we apply Y, summation forces in Y should be 0. So how many forces we have in Y direction? 3. YA, YB, and
QL.
QL 10 kilonewton. So, and also we know that the horizontal direction for Y direction is up, is the positive. This is the sign convention for this is the positive directions. This for X and this for Y. Okay, so YA going upward, so we have YA plus YB going upward plus YB. Okay, and for the 10 kilonewton going upward or downward, so negative 10 should be 0. Okay, this gives us that YA plus YB is equal to 10. Okay, the last question, can we get YA or YB from this equation? Can we? We can't, because we have two variables, so we cannot find YA or YB. So we will find YA and YB from M, summation moment. How can we apply this equation? To apply this equation, we can use apply this equation at point B or at point A. If we apply at point B, so summation moment at B should be 0. Okay. So what cause moment at B? If the force passing through the point, so this force doesn't have moment at B. So we have only 10 causing moment at B and YA causing moment at B. The moment at any point equal to the force multiplied by distance or eccentricity E. Okay, let's say by distance X. So any moment equal to force multiplied by distance. Okay, so what cause moment at B? We say 10 and YA. For YA, so YA multiplied by the distance from B. How much is the distance from YA to B? 5 meters. So YA multiplied by 5. And for 10, where this force applied 10? Do you know?
2.5 meters.
Yeah, at the middle of the span or at the middle of L. So this distance is L by 2, which is 2.5 meters. Okay. So the force 10 multiplied by the distance 2.5 meters. This should be equal to 0. But what is the sign for this moment and this moment? Do you know?
Yeah, that moment is YA is positive because it's clockwise. The other one is
negative because
negative,
it's
is anti-clockwise.
Yeah, for the moment you can assume what is the positive direction. So you can assume it is clockwise is the positive direction like this. So if the force is rotating clockwise, it is positive. If it is rotating anti-clockwise, it is negative. So for YA, it is rotating in this direction. So this clockwise or anti-clockwise? Clockwise. So this means positive. For the 10 kilonewton, it is rotating in this direction. And we are looking at from B. So at B, this force 10 is rotating anti-clockwise, so it should be negative. Okay, this means that we have YA multiplied by 5 minus 10 multiplied by 2.5 equal to 0. This means that YA will equal to 5. Positive 5. What means positive 5? If it is positive, it means that the force is acting upward or downward. Upward, because our assumption that Y is positive upward. Okay, so we can now know that YA is 5 kilonewtons. And for YB, how can we find YB? If we return back to this equation, and we know now that YA is 5 kilonewtons. So from this equation, we know that YB will equal to positive 5 kilonewtons. Okay, this means also that YB is acting upward. So we have now YB equal to 5 kilonewtons. Okay, this very simple beam, and that is the reaction. So we have YA equal to 5 and YB equal to 5. Okay. So let's save this one. Okay, now after we know the reactions, this is our beam. Okay, and we have load here. The load was uniform load 2 kilonewton per meter, and we concentrate this load to be 10 at the middle, and we calculate the reaction. The reaction was 5 kilonewton at A, this point A, and this point B, and 5 kilonewton at B. Okay, and the distance between A and B was 5 meters. Okay, then after that, we need to draw the shear force diagram. So I will create a datum here. Okay, so we have two guidelines here. Then we will do the datum. Okay, so this is the datum. On this datum, we will do the shear force diagram. How can we draw the shear force diagram on this beam? Do you know? To draw the shear force diagram on this beam, we have two sections to calculate the shear at. We will create section 1 at the beginning of the beam. So this is the beginning, just at the beginning of the beam, and at the end of the beam at B. So this section 1 and this section 2. And because we have only the uniform load, so we only have two sections, one at the beginning of the uniform load, one at the end of the uniform load. At the beginning of the beam at section 1, this section cut the beam to two sections, two parts, one at the left and one at the right. So it is easier for shear force diagram. We calculate from the left, not from the right. Okay. And from the left, if the force is going upward, this means the shear will be upward. If the force is going downward, this means the shear will be downward. So at 1, what causes shear at 1? Shear force means the forces parallel to the section. Section 1 is vertical, so what is the force cause shear? 5. Do you have any other forces? Do we have any other forces? We don't have any other forces. So we will have 5, and this 5 is going, as you see, upward. So we have 5 upward. Okay, this point is at 5 kilonewton. Okay, from 1 to 2, what is the forces we have from 1 to 2? We have 10 kilonewton. So we have 5 positive and 10 is going downward. So we have minus 10. So we will go to negative 5. -5 at point B. So at point B, at section 2, we go upward 5 and go downward 10. So the force or the shear force will be also 5 kilonewton. Okay, and from 1 to 2, because we have uniform load, we connect these 2 points with a straight line. Okay, so this is the shear force diagram we have. We have here 5 kilonewton. At A, and we have 5 kilonewton at B. And the sign convention for this one, above the datum is positive, below the datum is negative. Okay, so the shear force diagram, positive up above the datum, negative below the datum. Okay. Do you have any question for shear?
Sorry, I don't really understand datum. So is that sort of a 0 point or?
This one?
Yeah. And no,
Yeah.
the beam.
Oh, this one, the black one?
Yeah.
This is the beam, but I just, because we are doing shear, so I just remove the support. So just a horizontal line. But if you want to draw the support again, this is the support here. And this is the support here. Okay.
Yeah. Can
Yeah.
you reverse the shear as well? Like one side is, say section 2 is positive and section 1 is negative.
Section 1 is negative. Section 1 cannot be negative for this one.
Yeah, I just
What?
Sorry.
What do you mean by section 1 negative and section 2 is positive?
I don't know. I just can't.
We are just following the forces we have, because we have at one we have only the 5 kilonewton upward. So we go from 0, because we always start from the datum, the black line here, this 0. So we go from 0 to 5 because we have the 5 kilonewton upward. Okay. That's why we go up. Then from this point 1 to point 2, what forces we have? The 10 kilonewton, right? So we have 5 upward minus 10 downward. So we should be below the datum or above the datum?
Well, you're saying below the datum because it's going down.
Yeah, because we have only 5 upward and then we go down in 10. So we should be 5 below the datum, right? So from here to here, we have 10 kilonewton going down. So this 10 kilonewton bring us from 5 to -5. Okay. Then because we don't have any concentrated load, we have only uniform load. So we connect these 2 points with like a solid line like this, or a straight line like this. Okay. Then after section 2, we have 5 kilonewton. So this 5 will bring us again to 0. Okay.
Yeah.
You want me to repeat again for this one?
Yeah, that's fine. I'll go through this again.
Okay. And then the second step is the moment. So we have the moment next. Clean this one. Okay, for the moment, again we have our beam. Yeah, and this is the support. We have one support here and one support here. And we have uniform load Q equal to 2 kilonewton per meter. And we concentrate this load to be 10 at the middle. Okay, so we have 10 kilonewton. Okay, and the reaction we got 5 kilonewton here and 5 kilonewton here. Okay, and this distance is 5 meters. Okay, if we draw a guidelines here, sorry. And we got the data. The datum is the beam again, just to draw the moment on the beam. Because this data, and if you want to do to put the supports again, this is the supports. And this is the other support. Okay. And the moment to draw this moment, you should keep in mind. If we have a uniform load on a simply supported beam, the biggest moment or the maximum moment will be at the middle. So our maximum moment will be somewhere here at the middle. Okay. And we have two sections also to know. So we have section 1 and section 2. And the maximum moment is at section in the middle or the middle span is section 3. Okay. For section 1 and section 2, because this is the two ends of the beam. And again, this section divides the beam to two parts. One part from the left and one part from the right. And it is easier to go through from the left because we have almost nothing here, only one load, which is 5 kilonewton. Do you know what is the moment at section 1? And we are drawing the bending moment diagram. Do you know Kamel or Lynn or Brendan?
No, I'm sorry.
I multiply by 0. There is no distance there.
Yeah, because there is no distance at 1, so the moment is 0, because 5 multiplied by 0 just make the moment is
0.
So the moment here at any beam, if we have the start or the beginning of the beam, the moment should be 0. And similar to section 1 at 2. Section 2 divides the beam also to two parts. This part from the right and this part from the left. It is better to work from right or left for this section? From right, because we have only one force here, which is 5. Again, 5 is passing through section 2. This means that the distance is 0. This means that the moment at 2 also will be 0. Okay. The moment at 3 for any beam has uniform load, the maximum moment, M maximum, is positive moment and equal to Q L squared divided by 8. This value you should keep in mind. If we have simple beam like this and we have uniform load, So the moment should be positive and equal to Q L squared divided by 8. Positive, the sign convention for the moment, if this is the datum, above the datum is negative, below the datum is positive. This is the moment. So the moment is the opposite of shear and normal. Above the datum negative, below the datum is positive. So at section 3, the maximum moment will be below the datum or above the datum? Below. And what is the value of this moment? If we substitute in this equation, Q equal to 2, L equal to 5. So the moment will be 2 multiplied by 25 and divided by 8. And this value will be 6.25. Okay, so the value of the moment at section 3 at the midspan is 6.25 kilonewton. Okay, now we know the values. The last step is how to connect these 3 values or 3 points. We connected these 3 points with a solid line or a curve. This curve is not good. You know, do you have any idea how to connect them? Do you have any idea, guys, how to connect them?
Sorry, no idea.
Idea? Have
Is
you
that curved or?
Yeah, this would be curve. Okay, and the other one as well would be curve. Okay, and this one is, sorry. So we connected these 3 points with a curve, a parabola like this one. Okay, so we connected these 3 points with a curve, and this curve is a 2nd degree parabola. Okay, so we connect this with a 2nd degree parabola. So the maximum value is here at the midspan. And how much is this value? This value is 6.25, which is equal to Q L squared divided by 8. And what is the sign for this moment, positive or negative?
Positive.
Positive
Under-
because it is under the date.
Yeah.
Okay.
Positive.
Okay. So you should keep this value in mind. If you have simple beam and uniform load, the maximum moment will be at midspan and equal to QL squared by 8. Okay. And we connect the maximum point with the 0 with 2nd degree parabola or parabolic curve. Have you heard about this before?
No.
A long time ago.
Okay. We that's the only case we need to know for this course, the simple beam, because the rafter is our rafter is simple, so the value will be the moment on the rafter will be QL squared by 8. Okay. And your job at the beginning of assessment 2 part C is to find Q. Q is the load combination from all the loads you have, like wind load, live load, and dead load. Okay.
Well, that's great. Thank you.
Did you get it? Do you have any question for moment and shear? We can
So-
go through it again in the next weeks if you still cannot get it.
Yeah, sure.
That'd be good. Thanks. Give some time to digest this.
Okay, that's good.
That's
when,
good.
yeah, when we need it again, we can explain another complicated example.
Yeah, thank you.
No worries. I will stop the recording now for this one.